Hello and welcome. This is Cracking the Cryptic app, Fog of War pack number 1. I've decided to do them in the release order. The rules are Fog of War. Correctly placed digits clear the fog around them. Classic. Every row, column, and box must have all numbers from 1 to 9 exactly once. Thermometer. Numbers must increase as they move along thermometers starting at the bulb. And Partial Kropki. A white dot between two cells indicates that the neighboring digits are consecutive. A black dot between two cells indicates that one of the digits is twice as big as the other digit. Not all possible dots are given. Let us begin. So this is the thermometer. We don't know how long it is or if it curves somewhere. But this is the bulb, so this is the lowest possible value on it. And these are the black Kropki digits, meaning that a digit here with a digit here is such that this is either double the value of this or the opposite way around. This is double the value of this. All right, so immediately we make an observation. These values could not possibly be 5, 7, or 9 because nothing doubles into these values. And if you take these values and multiply them by 2, you get with the digit over 9. That's why this can only be 1, 2, 3, 4, 6, 8. Let's take a look at this cell in specific. Can this possibly be an 8? Well, if it was an 8, then you can put a 4 on one side, right? You could make this 8 and then this 4, if we disregard the thermometer completely. So 8 and 4. But what about this square? You would not have an ability to divide 8 by 2 again, because this has to be a unique value, so you would have to multiply it by 2, and that will make it a 16, so that doesn't work. So an 8 cannot be here. What about a 6? Again, if a 6 was here, then maybe a 3 can be down here. But you can't, for this side, you cannot again fulfill that same condition, because then you have to multiply 6 by 2, and that's a 12. And obviously this cannot contain a 12. So the 6 doesn't work either. And the same issue happens with the 1 and the 3. So this can only be 2 and 4, because, for example, if there is a 2 here, you can have a 1 here and a 4 here, and all the black cell conditions are fulfilled. However, if this was a 2, this would be a 1. But this is a thermometer. In a thermometer, the lowest possible value is always in the bulb of the thermometer. So if this is a 1 and 2, since a 1 is here, nothing could possibly be here, and the square would be empty. That's why a 2 cannot be here, and it must be a 4. So before we fill in the 4, we will quickly just fill everything else with all the possible values that things could take. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, 7, 8, 9. And we know that this is a 4. And since this is a 4, and the thermometer always starts with a lower value and goes upwards, that means that this is the 8, and this is the 2. So the only cell that could be here is a 1. This revealed two thermometers to us. With this left one, we don't really know where it goes to. After here, we know it's at least here, and then maybe it goes further out, but we don't know if this is a bulb or if it just is another body of the thermometer cell. But with this one, we see the whole thing. So let's start with that one. 1, 2, 3, 4, 5, 6. So it's 6 cells long. And that lets us know something. That means that a value of 5 cannot possibly be here, because if you count downwards, you would reach a 0. So this cannot be 5, 4, 3, 2, or a 1. And it's the same with this thing. This cannot be 4, 3, 2. And then this cannot be 3, 2, or a 1. This cannot be a 2 or a 1. And this cannot be a 1. All right. It's the same way the other way around. Basically, this cannot be a 9, right? Because, of course, this wouldn't be, it would be impossible to fill in everything. So, if we come from here, 1, 2, 3, 4, or rather 9, 8, 7, 6, 5, 4, we know that 4 is the highest possible value that this thing could have. So it cannot have 5, 6, 7, 8, and 9. And that's why this cannot be 6, 7, 9. This cannot be 7, 8, 9. This cannot be 8 or a 9. This cannot be a 9. All right, perfect. Now, if you take a look at this, these three cells are consecutive. That's what the white dot between them tells us. And this value over here, it cannot be a 4. Since that cannot be a 4, that means that this cannot be a 3. And since that cannot be a 3, that means that this cannot be a 2. All right. With that, we don't really have much else to do with this thermometer, so let's focus our attention on this one. We see the top of the thermometer, so we know that this is the highest possible value it could have and that it goes downwards towards here. So let's start. Let's assume that this is the bulb. The argument is going to be fine even if it's not the bulb, but we are assuming that it goes from there because we know that this is a part of the body of the thermometer. So 1, 2, 3, 4, 5, 6, 7, right? That basically means that a value of 6, if this was a 6, then that would be 6, 5, 4, 3, 2, 1, 0. See, that doesn't work. So values of 6 and lower cannot be there. 4, 3, 2, 1. And now let's keep doing this. 6, can 6 be here? Yes, it can, but 5, 4, 3, 2, 1 cannot. And then 3 can be here. And now that is quite interesting. You'll see that because there's a 4 and 2 and a 1 here, this thing gets a bit scuffed. So 5 can be here, 3 can be here as the lowest possible value. But that creates a little bit of trouble. So 7, 6, 5, and then this is 3. And then what would this be? This would be nothing. So that means that this thing cannot be a 7. It must be a 9. Because 7, 6, 5, 3, and then this will be a 5. Therefore, this is a 9. All right. Now, 9. Let's assume this is a 6. So, 9, 6, 5, same issue. So, this must be a 7. 9, 7, and then this has to be a 6 because they're consecutive. And then this obviously cannot be an 8. So since this is 3, 5, and this digit is higher than this one over here, this must be 5, this must be a 3, and then this must be a 2, and indeed this was the bulb. All right, so this is a 4, and there is an 8 over here. Perfect. So something else revealed itself to us here. First, let's just get rid of everything here. So this cannot be 7, 8, 9. 7, 8, 9. Basically, this thing, 1, 2, 3. All right, so this cannot be a 4, because if it's a 4, this would be a 5, and then this would be a 6, but there's no 6 here. So this cannot be a 5, and then this cannot be a 4. All right? Let's take a look at this one. How long is it? 1, 2, 3, 4, 5 cells long. All right? That basically means that this thing, the thing is fine actually. So 6, 7, 8, 9, that's fine. 6, 7, 8, 9. So a 6 cannot be here. The highest value we can start with is 5, 6, 7, 8, 9. Okay? What about the lowest values? 9, 8, 7, 6, 5. All right? So this one cannot be, oops, this one cannot be a 1, obviously. But other than that, this seems fine. So 1, 2, 7, 8, 9. So since these values can only be 7, 8, 9, obviously this is a 9, this is an 8, and this is a 7. And now it revealed another thermometer over here. All right, let's take a look at it. So this is the bottom of the thermometer, and let's start counting. 1, 2, 3, 4, 5, 6. So no value lower than 6 is allowed to be here. 5, 4, 3, 1 cannot be here. 4 and 2 cannot be here. 3 and 1 cannot be here. Oops. 2 and 1 cannot be here. And a 1 cannot be here. 9, 8, 7, 6, 5, 4. So no value higher than 4 could be here. So this cannot be 5, 6, 7, or an 8. This cannot be 6 or a 9. This cannot be an 8 or a 9. No. Hold on a second. Since this is 4, this is 5, that means that, if a value of 5 is here, then this would immediately be an 8. That's gonna cause some trouble. But because, as we said, the value 4 is the minimum, the maximum value here. It will be 4, 5, 6, 7, 8, 9, right? But there is no 6 here, and there's no 7 here either. So this cannot be a 4. Can this be a 5? Nope, same issue. So this cannot be a 5. Obviously, this cannot be a 9 or an 8. Oops. All right, so let's try 3, 4, 5, 6, 7, 8, or 9. This seems to work. All right, so 6 can be here as the lowest value. So 7. Wait a second. So 4, 5, 6, 7, 8, 9. This is fine, actually. These are all the lowest values. All right. So what do we know? We know that these values are consecutive. 3, 4, 5, all right. But there is no 2, 3, 4 because there's not a 4 there. So this cannot be a 3, and then this cannot be a 2. Okay. I suppose, let's take a look at this thing. Can this be a 1? Well, first, we see that there's a pair here. So anything around there cannot be a 3 or a 5. So, next question, can this be a 1? No, because there's not a 2 here. So this can't be a 1. Oops. And the same issue is here. This cannot be a 1 because we see that the bulb, this is not a bulb, right? A 1 can only ever be inside the bulb. And the thermometer continues downwards, so this cannot be a 1. Right? So can this be a 2? Probably. We don't know which side the thermometer goes for, so 2 has a 4. But can this be a 3? No, because there's no 6 here. And can it be a 6? No, because there's no 3 here. So that means that this is a 4. And now this is 2 or 8. We don't know which one because, again, we don't know which side the thermometer goes from. All right, so this cannot be a 9. One, two, three. 6 is the lowest value here, meaning that this cannot be a 5 or a 6, and this cannot be a 6 or a 7. Okay? There's a pair here, 2, 4, and 2, 4. So we know that this is not 2 or a 4. And there's a 6, 7 pair as well. 6, 7. So, since the lowest value here is 6, that means that this cannot be a 5 or a 6. And then this cannot be a 6 or a 7. So there is also a 7, 8 pair here. And there is an 8, 9 pair here. Okay. There's a 1, 3 pair here. What can we do next? So over here, we see that the thermometer goes down that way. So this cannot be a 1, right? And this thing cannot be a 9. And since these two are consecutive, this can either be 3, it cannot be a 4. Oops. Can it be a 5? Nope. But it can be a 6. And it can be a 7. Okay. So if you look at this thing, immediately what you see is that this is the only place a 1 could be. And that unlocks some new squares. It tells us that this is indeed the top. All right. Let's check everything. So this is the 1. So since a 1 can only be in this or this square inside box 4, that means that regardless of the square where it is, a 1 cannot be here or down here. Now let's check the 2. The only square where a 2 can be is right over here. And does that do anything? Let's see. This thing can still be 3, 5, 6, so not yet. Not yet, at least. All right. What about a 3? Where can the 3 be? Anywhere. 4. Okay. 5. 6. 7. 8. And a 9. Okay, so the only place a 9 can be is here. And that means that we should recheck 1, 2, and 8. It also shows us the direction that this is facing, right? So this is the top of this thermometer. So that means that this 4 can only go upwards from here. This can only be an 8, making this the 9. All right? So this must be lower than 4. So this has to be a 2, and then this is the top, making this a 1. And since 1 can only be here in this box, that's a 1. This then cannot be a 3. And this cannot be lower than 6. All right? So this is a 7. Then this is 6, 5, 6, since they're consecutive. There's a 3 up here. 1, 2, and 3. 3, 4, 5, 7, 8, 9. There's an 8 here. 7, 8, 5, 4, and then since there's a 5, 6 pair, this is a 3. There's a 2 down here. Let's go back to the 1s. Okay, so since a 1 is either here or here, that means that 1 cannot be down here. So since, let's assume that 1 is here, then it has to be here. So both of them make sure that it cannot be here, and that's how the argument goes for any possible position where they can be in these two squares. So basically it must be here. So 1, also a 1 cannot possibly be here anyway because this is a thermometer, so it has to be a 2, making this a 1, making this a 1, then this is 3 because they're consecutive, this is 6, and since this value must be higher than 6, it must be a 7. 9, 4. Since they're consecutive, this is a 3. And then this must be lower than 3. And the only digit that can be lower in this context is 2. 6, 5, 9, 4, 3, 6, 7. And then we just fill in everything that opens up to us. This is why I like putting all possible values, because once you like solve the main puzzle, things just kind of unlock, and then you can mindlessly just fill them in, and the puzzle will just completely unravel very, very quickly. And that's it. That's the puzzle done. Hope you guys enjoyed, and see you next time.